Okay, so we're looking at a situation. This girl, Claire, is filling her pool. So let's look at the table. After no time has passed, is there any water in the pool? No, obviously, okay? She checks the water level after an hour. So after 1 hour, she noticed that what happened? It increased by 15 centimeters. Then, pay attention here, she checks it again after another hour. And what happened to the water level? It went up by what again?
15.
Okay, now this is where you have to be careful because even on your EQAO assignment, some of you did not pay attention to the numbers in the table. She did not check it after 3 hours, 4 hours, 5 hours, 6 hours, or 7 hours. She decided, you know what, I'm going to go look at it at 8 hours and I'm going to record how many centimeters of water. Well, what do you notice is happening every hour? It increases by what?
135.
By 15 centimeters. So I want you to actually right now fill in
I'm done.
on the side. You're going to make a table on the side so that we can look at the pattern. If it's going up, we're trying to see if it's true that it's going up by 15 every time. We have to see that if we add 15 every time, according to that pattern, is it going to get us to 120 centimeters for 8 hours? So if 2 hours, after 2 hours it was 30, what would it be after 3 hours? If we're going up by 15, what's 30 plus 15?
45.
Okay, if we add 15 every time, at 8 hours, it does get us 120 centimeters. So we know that has to be the pattern. It goes up 15 centimeters for every hour. So what would be an equation that you could use to calculate the water level? How would you calculate the water level? W equals, what is it changing by every hour? So 15 times the number of hours, right? That's what you're doing. And actually, so you can use that equation for 9 hours. Well, you take 9 and you multiply by 15 to get the water level. Good. What is it for 9 hours?
Oh, it's 135.
Okay, so you can use the equation or you can just keep adding 15 every time. For 10 hours, what is it?
It's 150. And then it's
11 hours.
165.
12.
180.
Good. Is this relationship direct or partial?
Yeah.
Is it going to be direct or partial? Look at where it started. It started at 0, 0. If you have no hours passing by, then you have no water in the pool. It started with no water. I want you to write that on the top as well. It's direct. Extended the table, and you could have looked at your table. This is when the water level, the pool is full. They could have stopped after 10 hours, okay? You could use the table or you can use the equation. Is this a linear relation, yes or no?
Yes.
How do you know?
Because it goes up by the same number.
It's a straight line, yes. It goes up by the same amount every time. So increases by the same amount, which means it has a constant rate of change. And we also discussed that it was direct. If it's a direct relationship, we automatically know it has to be linear. It goes up by 15 centimeters for every hour. So the pool is full when the water level is 150. So when W equals 150, the pool is full. We have to figure out how many hours did it take for it to get to 150. So can you use this equation? If W is 150, I'm going to write 150 equals 15H. We're trying to figure out hours, right? If the water level is W, replace W with 150. They're telling you if the water is 150 centimeters deep, how would I calculate how many hours? What do I have to do to find H? Divide it by 10? It's 15 centimeters per hour. So what is
10,
H equal
10,
to? 10. You were giving me the answer. It took 10 hours for it to get to 150 centimeters. You could have used a graph. Okay, so use the equation again. The equation is W equals 15H. Figure out what is W equal to. What is the water level after 5 hours? So what am I going to do to calculate the water level after 5 hours? W equals 15, what? Times 5 for 5 hours. What's 15 times 5? So the water level is 75 centimeters after 5 hours.